So again, we see differentiation. So let's see for the different types of examples. Let's say y is 2x times x squared plus 3 to the power of 5. So then, okay, let me just make it simplify a little bit. So let's say like this. So then this one, again, by the procedures, by the patterns, and we try to like go through exactly like the concept. So then later we will find that what we can do is just the same like before. So we can assume that this part is, let's say, like x or a or something. So then it goes like 2a power 5. So then if we apply exactly what we had before, the pattern, so what we should do is like 2 times 5 times a to the power 4, right? But the thing is, the a here is actually a function, right? So it's actually a function. So then that's what I mentioned in the class. It's like an onion, like peeling something. So you go from the very outside part, which is in this case is the index, the 5, and then you're done with the 5, then you go to the inside part, which is the x squared plus 3. Then you derive it once again. So that's the analogy, like this. Then you can go like 10, you put back the a, which is x squared plus 3 to the power of 5 times 2x plus 3. So then after this, it depends on whether we need to simplify or not. It's up to you. Then usually the question comes with find the gradient or find the tangent line. If it's just find the gradient, let's say at x equals 0, then what is the gradient? We just plug in basically, because that's the meaning of dy dx. That's the meaning of differentiation, right? As you see from the previous video. So then we got like 10 times 3 power 5 times 3. So then it's like 10 to the power times 3 to the power of 6, and then we get that number. So it's kind of like that. So then the thing with this part, which is there is this the 2x plus 3. So then the mathematicians call this as chain rule. That's why if you see this, it's actually the dy dx can be represented as, like, for example, in the case of this, dy over dA. What does it mean by dy dA? Because, for example, we change it with a, right? So then it becomes like y to a power 5. So then we don't have the x anymore. So then instead we derive it dy with respect to a. So then it becomes 10a4. But then once again, it's not the a that matters, but the x. So then we have to times it because they are connected. That's why it's like the chain rule. They are connected over the x. So then it goes like, we can actually like cross it out. So then it becomes a dy dx. You see, right? So that's the idea of the chain rule. Hopefully that helps.